So this video is meant to help you understand how we measure the field of view in a microscope. It's really important to know the field of view in all of the powers of your microscope so that you can estimate the size of specimens that you are looking at. So there's definitely some math involved, and a calculator will definitely be helpful. We have these notes that I prepared for you, and let's dive in. Let's take a look. First thing first is, let's just identify a field of view is the area that you look at in the microscope. When you look into the microscope, you see a circular, a circle of light, and that circle of light is your field of view. What we need to know now is, what is the diameter of your field of view? We need to know, if we know that diameter, we can then count up the number of cells that go across the diameter, and then from that we can do the math to figure out the diameter of each one of those cells. Okay, so first we're going to figure out, how do you go about measuring that field of view diameter? And there's two ways that we can do it. The first way is to directly measure that field of view. You can see here, this is a picture of a ruler. You would want to use a clear ruler on a microscope stage so that light can pass through it. And what you'll actually do is you'll be seeing a ruler through it or in your field, and you're actually measuring it directly. Okay? So we're going to assume that the lines in these fields of view are each equal to 1 millimeter. And if we look at these three, if we had to guess, this is probably the high power because we see only a couple markings here. So what we are looking at is the distance from here to here is 1 millimeter. So 1 millimeter, 2 millimeters. And then if we patch these two pieces together, this is about a has 3 ruler spaces. So this is about 3 millimeters of a field of view. Okay. Now, sometimes it's helpful to, because even a 1 millimeter is it's a very big measurement when you look at it under a microscope, even though in reality 1 millimeter is very small for us as humans. So it's going to be helpful to know that 1 millimeter is 1,000 micrometers. So if you've measured your field of view to be 3 millimeters, we know that that is the same thing as saying 3,000 micrometers. Okay. So if you see a U or a funny little U right in front of that right there is the symbol for micrometers. If we look at, let's go to this image right here, of the 3 images, this is the one that's sort of medium magnification, so we'll say that this is medium power. And if we count up the spaces, I see 1, 2, 3, 4, 5, 6 full ruler spaces, plus one more, that's about 7 ruler spaces. So this is about 7 millimeters wide. And if we multiply by that by 1,000, we get 7,000 micrometers. Over here in this is probably the low power. If we count up the ruler spaces, we've got, or full ruler spaces anyway, 1, 2, 3, 4, 5, 6, 7, 8, 9. Patch those together, we've got about 10. Let's count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. I would say that's about 10 ruler spaces. I feel like I'm counting that wrong. Yeah, maybe this is a full one right here. So I think this is actually 11 total ruler spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. So that means we are looking at a field of view of 11 millimeters. And of course, that means that we have 11,000 micrometers. Okay. So what we have just done, we have determined the field of view diameter by directly measuring it with a ruler, looking at the ruler through the microscope. Well, sometimes you're going to find that under high power, you're not even going to see a full millimeter. You might see less than a millimeter, in which case it's really hard to directly measure it. So in this case, we're going to have to use a proportion. Okay, and so to use a proportion, which is cross-multiplying, measuring field of view diameter by cross-multiplying. All right, so it's a ratio. If you know the magnification of your low power, if you know the magnification of your low power, and you know the field of view diameter for your low power, you can calculate the field of view diameter for any of the other powers using this formula. What we see here is we have the high power magnification divided by the low power magnification equal to the low power field diameter over the high power field diameter. Okay, so what do we notice about this equation? Well, if we look at this equation, magnification is on the same fraction and field diameter is on the same fraction, but notice that high and low, low and high. So the highs and lows are reversed, right, on either side of that fraction. So let's try an example. What we have here is 40x. This is a 40x magnification. That's one of the things we need to know, right? We need to know the magnification of your low power, and we need to know the field of view diameter for your low power. So there is our magnification. Here's a millimeter ruler, and under low power, I see 1, 2, 3, 4. I'm going to call this about 4.2 millimeters. So there is our field of view diameter at low power. Okay, so using those two numbers, we can find the field diameter at medium power, which is 100x. So let's set this up. The higher power magnification in this case is 100. So I'm going to put 100 up top. And the lower of those two magnifications is 40. So the higher magnification of 100 over the lower magnification of 40. We're going to set that equal to the field diameter of the low power, which we measured was here, 4.2 millimeters. And what we're trying to find is the higher power field diameter. We're trying to find this medium power field diameter. So that's going to be our x. Okay. So if we cross multiply, we have 100 times x is equal, 100 times x is equal to 40 times 4.2 millimeters. Okay. We want x all by itself, so we're going to divide that by 100. The hundreds over themselves cancel out. And now we have the math to do in your calculator. So let's see what that looks like. So this is 40 times 4.2 equals, divide that by 100, and we get 1.68. So 1.68, notice this millimeters did not cancel, so that's our unit. So this is the medium power field diameter. So under low power, we could see 4.2 millimeters. Under medium power, we could only see 1.68 millimeters, which makes sense. We magnified the image, so we're seeing less of it. Right? So let's try using this information to figure out what's the field diameter when we make the power go to 400x. Okay? So let's take a look at our equation right here. Our higher power magnification this time is 400. Our low power is still 40, going back to the original. Our low power field diameter is still 4.2 millimeters. It's that high power field diameter that we're trying to figure out. So cross multiplying, so this is 400 times x is equal to 40 times 4.2 millimeters. We want x all by itself, so we have to divide this side of the equation by 400. And what we do to one side of the equation, we have to do to the other. So this 400 and this 400 cancels. So our math becomes 40 times 4.2, divide that number by 400. So now our field of view is even smaller at 0.42 millimeters. That's our field of view, that's our high power field diameter. which makes sense. We're seeing less and less of that field as we magnify more and more. Okay, well, now we've spent a lot of work doing two things. We first measured the field of view diameter by directly measuring it. If we couldn't directly measure it, we had to use a proportion, and we cross-multiplied. But both of those skills that we just worked on were finding the diameter of your field of view. Okay. So what's all this fuss about finding field of view diameter? It's because what we're trying to do is find a way to measure the size of the specimens that we're looking at. So here's the math that you're going to need. In order to find the size of the object that you are looking at, you need to know two things. You need to know the diameter of the field of view, which we just spent some time figuring out how we got that information. And number two, you're going to need to count the number of times the object fits across that field of view. We're going to divide those two numbers. Okay. So once we have those, we can do the math. So let's try it with this example right here. We've got onion cells. The magnification is 100x. And our field of view is 1800 micrometers. So that means the distance across the diameter is 1800 micrometers. Okay. So what's the width of a single cell? Okay. Well, the width, going back to this equation, we need to know the diameter of our field of view, right? So it's already been determined that our field of view is 1800 micrometers. We're going to divide that by the number of times the objects fit across the field of view. So let's take a look. We've got some cells here, and try to find the cells across the diameter. I've got two full cells, right? Two full cells, plus these other cells which are kind of fitting across. So let's say that this cell plus this cell, if you patch those together, we maybe have about a half a cell. So we can fit about 2.5 cells across. Okay. So there's no unit here. This is just the number of cells going across. So now the calculator work comes in, and we want to do 1800 and divide that by 2.5. And so what we see here is that a single cell going across right here is about 720 micrometers. So that's our answer right there. What's the height of a single cell? Well, this is really no different, but now we just have to think vertically. So this field of view right here is also 1800 micrometers because it's a perfect circle. So the height is equal to the field of view of 1800 micrometers, and we're going to divide that by the number of cells that we can stack going up vertically. So let's count the full cells. I've got 1 full cell, 2 full cells, 3, 4, plus a little bit more, and if we patch those together, I'm going to say that that's equivalent to a full cell height. So we can fit 5 cells are stacked high. So 1800 micrometers divided by 5, 1800 divided by 5, and so it looks like the height of each cell is about 360 micrometers. So this height right here is about 360 micrometers. All right, let's take a look at one more example, and then I'll show you which ones you can try. So now we have switched from a higher power, from medium power of 100x, we've switched up to 400x, so our field of view is smaller. So take note of that field of view being a little bit different. If we want to find the width of a cell, we need to take that field of view, that 450 micrometers, and we're trying to find the width, so we have to count across the diameter, and I would say that we have about 2 full cells going across, perhaps 2 cells across. So 450 divided by 2, 450 divided by 2 is 225. Right, so the width of this cell is 225 micrometers. What's the height of a cell? Okay, so the height, we still have the same field of view at 450 micrometers. And we can probably fit, let's see, 1, 2, 3, 4, 5, 6 full cells. And if I patch together this part of this cell and this part of this cell, I think we can have 7 cells stacked high. So 450 divided by 7 cells. If we do the math there, 450 divided by 7, we get about 64. Okay. All right, let's take a look at the examples on the back and show you a couple things that are a little goofy. All right, so just pay attention to the field of view, right? We're giving you what the field of view is for that particular magnification. So that should be pretty straightforward. Field of view here, 450, so that should be pretty straightforward. But then let's take a look at this example right here. We've got a field of view that's different, so pay attention to that field of view there. But what you have to now do, if you can't actually see the cells all the way across, at least on this paper picture of this cell, what we can do to figure out what its height is I'm just going to draw that structure, right, as if there were ones stacked. And I'm just trying to estimate, trying to draw this structure over and over and over. Okay, so I would say for this particular specimen that we can fit 1 full specimen, 2 full specimens, and then if we patch together this part and this part, I would say that we have 3 specimens stacked, right? So the length can fit about 3 lengths. And then same thing going the other direction. If we're trying to figure out the width, you know, just kind of sketch how many of these could fit across. And I'm going to extend it out past my field of view because remember you're trying to figure out going out to the diameter. And so, and this is also an estimate, right? So you're just trying to give yourself a little help in estimating how many can fit across. So I would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I would say 11 specimens can fit across. So that should help you try the problems that are on this last page. And remembering that what we were trying to do today is we're trying to figure out the size of your specimen. For that, you need to know to find the size of your object. You need to find the diameter of the field of view. In these problems, that's all being given to you. And then you divide it by the number of times the object fits across the field view. All right? Okay, thanks for listening, and we'll see you back in the classroom.